So look for these types of problems. You say p squared divides n to the fourth plus 1. Also consider it as mod. Because sometimes this one is useful, sometimes this one. We don't know, so we should check both. So can you tell me what is congruent to what mod what if you want to change it? Mod.
P divides. So n to the 4 plus 1 congruent to 0 mod p squared.
Yes. Or n to the fourth is congruent to what?
Negative 1.
Negative 1. If you write like this, it's better instead of n to the 4 plus 1. Because here we can raise to the, for example, power of 2 or power of any number, right? And it's easier to work, right?
Yeah.
Okay. So find the least positive integer m such that m to the 4 plus 1 is divisible by p squared. Okay, so p is the least prime number for which there exists an integer m. Okay, so here, can you tell me what have you done for this problem?
I wrote it into this mod format, basically. Then I tried
Yes,
and I
but look,
replaced.
at first here it says p is the least prime number, right? So
Yes.
we should find p first. And the most useful idea is what I told you before in also JMO AM.
Small example.
Yes, so we should use a small example on what?
On maybe p.
On p because we want to find p. So we should check, okay, for p2, is it possible? Then for p3, is it possible? And try to see, can you find p by a small example? So try to see, can you find p?
Okay. So I reached p divides n to the GCD p minus 1 and 8 minus 1.
P divides. Can you explain what have you done?
So I did p divide. So if p squared divides n to the 4 plus 1, then p divides n to the 4 plus 1 because p is the prime.
Yes.
And Fermat's little theorem says that p divides n to the p minus 1 minus 1.
And to the p minus 1 is 1 mod p, yes, then what? Because
And
p
I also
doesn't
said,
divide n, right? Obviously, because if p divides n, then p divides 1, right?
yeah.
Because
And
p
I
doesn't.
said p if p divides n to the 4 plus 1, then p divides n to the 8 minus 1.
Yes, from here n to the 8 is 1 mod p, then what?
And now I have it in that format. So p divides n to the GCD p minus 1, 8 minus 1.
Uh-huh. You use this. You said n to the p minus 1 minus 1. And a to the 8 minus 1 is n to the GCD of 8 and p minus 1 minus 1, right?
Mhm.
Then what?
Okay, from here I'm not sure.
One
So
hint or
p
one try?
yeah, I know p has to divide this, and I know that n to the 8 minus it has to divide n to the 8 minus 1, but not n to the 4 minus 1. The GCD has to be at least 8 or 8.
Yes, if, for example, if GCD of 8 and p minus 1, for example, is 1, then n is 1 mod p, right?
Uh-huh.
And then n to the fourth is 1 mod p. Also, we know that n to the fourth is negative 1 mod p. So p divides 2, p is 2. So we should reject why p is not 2, right?
Oh, yeah.
So try to reject why p is not 2.
Not possible because if p is 2, then n to the 4 plus 1 has to be divisible by 4, which is not possible because it's always 0 or 1 mod. What's it called? 4.
Yes, n to the fourth is 0 or 1. Mod 4, so it's not possible. So P is not 2. And similarly, we can reject GCD 2 and 4, right?
Yeah.
GCD 2 and 4, we can reach contradiction. So GCD is 8, right?
Uh-huh.
Then what can we say?
Smallest P is 17.
Yes, 8 divided by minus 1. Let me tell you a so much easier solution than this one for this part. So it's solution 1 that you use to prove P is 8 divided by minus 1. Solution 1, let me tell you solution 2. For solution 2, as you said, n to the fourth is negative 1 mod P. And we know n to the 8th, so is 1 mod P, right?
Uh-huh.
So let's consider order of n mod P is, for example, D, right? Or this order is, for example, W, okay?
Uh-huh.
Because of these two, what can we say about W? I told you last session a theorem about order. We consider these two, what can we say about W?
But n to the 8 is going to go into 1 P. You can say W divides 8.
Exactly. Here I told you, look, this one.
Uh-huh.
If order of a n mod n is D and a to the m is 1 mod n, D divides m. Okay?
Mm-hmm.
So then we can conclude W is A. W divides H, right?
Yeah.
So W is 1 or 2 or 4 or 8. If W is 1, it means that N is 1 mod P. Again, same contradiction, right?
Yeah.
Then N to the 4 is 1 mod P. Then 1 is negative 1 mod P. Then P divides 2 and P is 2, right?
Yeah.
So that's a contradiction. So same reason for these two, we can reach contradiction, right?
Yeah.
And W is 8, right?
Yeah.
Okay. Look, this approach is useful in many problems. So you can do all these things in your mind. When you see, okay, n to the 8 is 1. Okay, W divide the order divides 8, but it cannot be 4 or 2 or 1 because of this. So W is 8, right?
Mm-hmm.
In one step, we can prove this. Okay. So 8 divides P minus, and n W, because W is 8, and we know n to the P minus 1 is 1, the rest is same. Mod P, then we can say, okay, 8 divides P minus 1. And from here, so the first key that we should check is what?
The P to check is 17.
Exactly. Now for 17, it says prove that there exists. If there exists, then find the least positive integer m, that this one is divisible by p squared. So check for 17. See, can you find any number? And if you can find the minimum one. Okay, try.
How do I proceed? I don't figure it out. I have to solve the final.
One hint.
Yeah.
Okay, so for P17, if you want to check, do you remember we solved a problem in AIME? It was for 1000, then we solved it for 8, and
Yeah. I remember.
then we changed it to 125, and then for 125, we first solved for 5, then 25, then 125. Remember that?
Yeah.
So here, because we want to find m to the 4 plus 1 be multiple of 17 squared, instead of 17 squared, for first we should solve it for what?
17.
Exactly. So m to the 4th plus 1 mod 17 is 0. Then you should
Okay.
try to find a mod 17 is what, and try to find all possible cases exactly You should use the approach that we use for this problem. Then use those numbers for 17 squared, okay?
Okay.
Right.
Okay. I think I got the answer after a lot of like checking.
Okay, so M can be what numbers?
2. It can be 2 mod 17, 8 mod 17, negative 2 mod 17, negative 8 mod 17.
Okay, let's check.
I just checked every single one basically.
Look, for example, if we check for 1, obviously it doesn't work, right? For 2,
Yeah.
because n to the 4 should be negative 1 or 16, right?
Yeah, you only have to check up to 8.
And we don't need to check. We only say, okay, plus minus 1, plus minus 2 bad. Plus minus 2, 1. 3 to the 4 is 81, right?
Mm-hmm.
Is negative 4, that's bad. Plus minus 4. When you want to calculate these, it's 16 squared, which is 1. Again, it's bad. Plus minus 5 is 25 squared, which is, we can say 8 squared. For 8 squared, you can say 64. It's negative 4, it's bad. Plus minus 6, you can say 36 squared, which is 2 squared, 4 is bad, right?
Mm-hmm.
Plus minus 7, 49 squared. So 49 is negative 2, right? It's 4.
Mm-hmm.
So why you said it was so much hard? Plus minus 8. 64 squared is negative 4 squared, which is 16, is good.
What do you mean why I say it's hard?
And finished, right?
Yeah.
Okay, so it took around 1 minute or at most 2 minutes, right?
Yeah, and then I checked also then I had to use binomial theorem to check the actual like numbers.
So look, m is plus minus 2, plus minus 8. So we have 4 answers, right? Now for plus 2, you should find minimum for each of them. You should find minimum number that mod 17 squared has
Yeah,
this
that's what I
property.
did. I did.
You found for each of them?
Yeah. I set m equals 17k plus 2. Then I used binomial theorem to get the term that's not divisible by 289.
There's 17k plus 8. 17k minus 8. For 17k plus 2, 17k plus 2 to the 4th is congruent to negative 1 mod 17, right? Mod 17 is squared, agreed.
Yeah, but you don't have to write it. Yeah, sure.
Okay, so you should find it is what?
Yeah, k is 9. I found it.
There is no k here.
Okay, so k is 9, or the lowest one.
You said k is lowest one is 9.
Yeah.
Okay, let's check. Here it says minimum m that is positive integer. Okay. You said k is 9. So we have similar to this one. We need to only write 2 to the 4 plus 4 times 2 cubed times 17k, right?
Yeah.
Okay. So 2 to the 4 here when you take negative 17, and we can divide it 4 times 8, 32k. It's congruent to negative 1 mod 17, right?
Yeah.
32k is negative 2k, right? And negative 1 is 16. So k is negative 8, which is 9 mod 17, right?
Yeah.
Exactly. What about 17k minus 2?
Got 8.
K is 8.
Yeah.
For 17k plus 8k is what?
8k, that's 6.
For 17k minus 8?
11.
So it seems this one is better, right?
Yeah.
So 110, right?
Mm-hmm.
Okay. Want to check other numbers you found, K8, K6, K11, or that's okay?
They're all greater than 110.
Yes. No, I mean this part that I solved this one and said K is 9. For the rest, I wrote only your numbers. Want to check them or that's okay?
No, I think I did them right.
Okay, so
Except 17 should just be 17 minus that number.
exactly. It's like this. You can check all these. I solved only one of them to see it's correct or not. So M is 100. Okay, so this problem was an application of order.